So what does it really mean to do science? For a lot of us, it probably brings up images of textbooks, maybe some bubbling beakers in a lab. But today, we're going to unlock a completely different way of looking at it, one that's way more active and creative than you might think.
Let's just tackle this head on. Is science really just a bunch of facts and formulas that you're supposed to memorize from a book? If that's what you were taught, well, you only got a tiny, tiny piece of a much bigger and frankly, much more exciting picture.
This quote just nails it, doesn't it? Think about learning to play the guitar. You can read all the sheet music you want, but that's not the same as actually playing. Science is exactly like that. It's not just about knowing the facts, it's a skill you have to practice. It's a performance you have to learn.
And that brings us to our first big idea. We've got to shift our thinking. Science isn't some static, dusty old product on a shelf. It's an active, dynamic process. It is something you do, not just something you know.
So let's break that down. Science is really two things at once. It's a product, right? Those are the facts and theories we read about. But it's also a process, and that process is the active investigation, the journey of discovery itself. Honestly, without understanding how we got the answers themselves don't mean nearly as much.
And that process has a name: scientific inquiry. This is the engine room of science. It's all about curiosity, asking questions, experimenting. It's the bridge that takes us from a simple question all the way to real, solid knowledge.
Okay, so how do you actually start doing science? Well, think about it like this. You can't cook a 5-star meal just by reading a recipe, right? You can't really do science either without first getting a handle on some fundamental skills.
Let's stick with this chef analogy because it's perfect. The scientific method, that's like your recipe, a clear set of steps. But to even use the recipe, you need the basic cooking skills. We call these the science process skills, or SPS. I mean, how are you going to follow a step that says, finely dice an onion, if you've never even learned how to hold a knife properly?
And that is the absolute key takeaway here. The big famous scientific method is totally built on a foundation of these smaller essential skills. You have to learn the individual notes before you can play the whole song. These skills are the bedrock of everything. So let's dive into a few of these fundamental skills. To keep our music analogy going, these are the core notes, the absolute basics you need before you can start putting together a masterpiece. First up, two words that get mixed up all the time: observation and inference. An observation is just the facts, okay? It's what you see, hear, touch, what your senses are telling you. The ground is wet. That's it. And inference is the next step. It's the logical explanation you create for that fact. The ground is wet because it must have rained. See the difference? One is the raw data, the other is your interpretation.
Here's another pair we need to get straight. A prediction is basically just a forecast based on a pattern you've seen. Like, hey, it's been getting darker all morning, so I predict it's going to rain soon. Simple enough. A hypothesis, though, is way more formal. It's a specific, totally testable statement that's designed to answer a question. Something like, if plants get more sunlight, then they will grow taller. It's not just a guess, it's a proposal you can actually go out and test.
Okay, so now that we have some of these basic skills, we can start putting them together. How do we combine them to design a credible experiment? In science, we call this creating a fair test. And the secret to a fair test, the absolute heart of it, is understanding and managing your variables. In any good experiment, there are 3 types you have to know. These are basically the moving parts that decide if your results are meaningful or just random. First, you've got the independent variable. This is the one thing, and only one thing, that you, the scientist, are changing on purpose to see what happens. Think of it as the cause. In that plant experiment we mentioned, the amount of sunlight would be your independent variable. Next up is the dependent variable. This is what you observe and measure. It's the effect. Its value depends on the change you made with the independent variable. So, you change the sunlight, and you measure the plant's height. The height is the dependent variable. And this last one might just be the most important of all, the control variables. These are all the other factors that you have to keep exactly the same to make sure your test is fair. Things like the amount of water, the type of soil, the temperature. Why? So you can be positive that the only thing affecting the plant's growth is the sunlight, the one thing you're actually testing. So, what's the whole point of this? Why are we bothering to master these skills? The goal isn't just to churn out more scientists and lab coats. No, it's something way bigger, and it applies to every single one of us.
The ultimate goal is to achieve scientific literacy. And listen, this is not about memorizing the periodic table. It is a powerful life skill that gives you the ability to think critically, to look at evidence, and to make smart, informed decisions about your own life and the world around you.
You know, the PISA framework, which is used in education all over the world, breaks this down perfectly. It says that true scientific literacy has 3 parts. First, you need some basic scientific content, just understanding how things work. Second, you have to get the scientific process, how we use evidence. And third, and this is the kicker, you need to understand the scientific context, how to apply all of this to real-world issues, like your personal health.
And this brings us right back where we started. This is the performance. Scientific literacy is you using the skills of science to navigate your world. It's the instrument you use to understand reality, to cut through all the noise, and to play an active, informed role in your own life.
So we'll leave you with this thought. Science isn't some book of facts collecting dust on a shelf. It's a set of tools, a way of thinking. You now have the fundamental skills, those basic notes. So the only question left is, how will you use them to read the world's complex and fascinating music?